All right, in this video, we'll finish out section 11.6. So first of all, it says here, probability is a measure of how likely an event is to occur. Expressing the odds of an event is another way. So let's go ahead and look at this. It says the odds against Derby King winning the Kentucky Derby were 5-2. Sometimes you would hear the odds on Derby King. So that's how we usually talk in terms of odds. What does this mean? And what was the probability that Derby King would win the race? So maybe look at that and see if you can figure it out or explain it, and then you can look at my explanation. All right, so what we have here is a ratio of unfavorable to favorable outcomes. In fact, the way I would explain this is if the race were held 7 times, 5 times Derby King would be expected to lose, 2 times he would be expected to win. So those aren't the best of odds, although for horses, those are actually good odds. So here's the thing, you have 5 unfavorable outcomes and 2 favorable. Notice the ratio doesn't indicate the total. To get the total number of outcomes, you just add the 2. And so often I'll write out my favorable, unfavorable, and total outcomes whenever I'm going to do an odds problem. So now we were supposed to indicate what the probability was that Derby King would win. Well, remember, the probability that he's going to win is the number of favorable outcomes divided by the total number of outcomes. In this case, there's 2 favorable outcomes out of a total of 7. So his probability of winning is 2/7. All right, so you can see I've given you or rewritten the definition for the probability of an event occurring. And then here are 2 ratios for odds against and odds in favor. So let's go ahead and do some problems and see how this works. There's nothing hard about this. You just have to make sure you understand the difference between expressing uncertainty in terms of odds versus the way we do it as probabilities. All right, so let's look at A here. It says find the probability. Well, let's see, Stephen rolls a die. Find the probability that he rolls a 5. Well, that's the number of favorable divided by total outcomes. So there's only one 5 on a die, so that's the favorable outcome out of a total of 6. So he's got a 1 in 6 chance of rolling a 5. We've done that before. In B it says find the odds against rolling a 5. Let's go ahead and write out the different odds, or I should say our favorable outcomes. The different outcomes is what we really want to write. We have 1 favorable, that's getting a 5. And there's 5 unfavorable outcomes. That's when we don't roll a 5. That's when we get a 1, 2, 3, 4, or 6. And there's a total of 6 possible outcomes here. So the odds against rolling a 5, remember our definition up above, it's this ratio of unfavorable to favorable outcomes. So that would be 5-1. Now, I don't like this. This is not the way I've seen this before, but I believe in this book there are at least a couple occasions where they write this as a fraction. Normally we express probabilities as fractions, but odds are usually expressed either with the word 2 in between or with the colon in between. But you may see that in the book. All right, on C it says find the odds in favor of rolling a 5. So in favor, this is the opposite basically of against. It's the ratio of favorable to unfavorable outcomes. So that would just be the opposite, 1-5. And again, we could express it as the fraction 1/5, but again, that's less common, at least from what I've seen. All right, let's look at D. It says find the probability of rolling an even number. So when you roll a die, of course, 3 of the numbers are even and 3 are odd. And so that would be 3 out of 6 or a half. Now it says find the odds against rolling an even number. So here we have 3 favorable outcomes and 3 unfavorable outcomes, and a total of 6. So odds against is the ratio of unfavorable to favorable outcomes. So here it's going to be 3 to 3, which we can reduce to 1 to 1. This is basically 50-50 odds. Half the time you're going to get an odd number, half the time you're going to get an even. So the odds against rolling an even number are 1 to 1. Those are even odds. All right, let's move on to the next slide. And so there's some problems here to help you to make sure you understand this concept and the difference between odds and probabilities. So I would encourage you to do these 2 problems and then check your answers. Okay, so the odds in favor of winning a door prize on a certain game show are 5 to 9. So those are odds in favor. So favorable to unfavorable is the relationship or the ratio. So I'm going to go ahead and write out my different outcomes. I have 5 favorable, 9 unfavorable. That's what this ratio is here, which means there's a total of 14. So find the odds against her winning the door prize. So we know if the odds in favor are 5 to 9, then the odds against will be the opposite, 9 to 5. Find her probability of winning. Oh, I'm sorry, don't forget, you could write that as a fraction on A. Probability of winning, it's the number of favorable divided by total outcomes. So here it would be 5 out of 14, 5/14. So on number 2, it says you are dealt 1 card from a 52 card deck. Find the odds in favor of getting a black ace. Well, let's go ahead and write out our outcomes. So we know we're going to, our ratio here, since it's odds in favor, are the ratio of favorable to unfavorable outcomes. So we have 2 favorable outcomes. That's when you get a black ace, right? Because there's the spades, the ace of spades, and there's the ace of clubs. So there's just 2 cards, 2 aces that are black in a deck. And so we have 50 unfavorable outcomes. And so our answer here, let's see, that's total 52. Favorable to unfavorable, that would be 2 to 50, which is 1 to 25. And again, you could write that as a fraction if you were asked to do that. So the odds against getting a black ace would be the opposite. Unfavorable to favorable outcomes, that would be 25 to 1. Find the probability that you will get a black ace. So that's the number of favorable outcomes divided by the total number of outcomes. That's 2 over 52, which reduces to 1 in 26. All right, and that's going to be it for this video.